present value is a really fun concept. It's one of the best applications we have of brief calculus and integration that we can kind of put together. So, very quickly, this function is related to the concept of compound interest, which that was the amount that you have in your account is equal to the P, which stands for principal, times E to the RT. So if you remember that formula, P is principal, the amount you put in the account at the beginning of your investment, R being the rate at which you are investing, written as a decimal, T is the amount of time measured in years. So you'll notice a similarity, right? They look very, very similar. The difference here is the present value is used for continuous income streams. That's why instead of using a P, we use F of T. What this is saying is maybe you're going to get $3,000 per year. So it's not going to stop after just 1 year. You get it repeatedly over and over. So where a principal is a deposit into an account, you don't keep depositing over and over. It's just a one-time thing. So that's why you have the F of T. And of course, if that number was changing, maybe this year is $3,000, but next year you're going to add another 500. And then the year after that, you're going to do another. So next year it'd be 3,500. Then the year after that'll be 4,000. So you might do a function like this, where you're going to do 3,000 plus 500t. So that's why we use function notation there. Okay, but for this problem, we'll just use 3,000. The R is again the rate written as a decimal. So for example, if we had a 4% rate, we wouldn't write that as 4%, we'd write that as 0.04. And now this T, for almost every problem that we're going to do in this class, is a variable. You're going to leave it alone because we're integrating. But this T up here, the capital T, that's the high end of our boundaries, that is going to be that where you put your time. So if we said we are going to continue to do this for 20 years, okay, well, actually, let's not do 20 because I did that right there in the next problem. Let's do it for 5 years, okay? So if we're going to do it for 5 years, that's what our capital T would be. So if we were to fill this in now, what we're going to say is, the integration would look something like this. From 0 to 5, 3,000 e to the negative 0.04 t dt. Now, before we talk about what this means, let's just get our answer. And I know I haven't done too much calculator stuff with you guys, so I want to do one in the calculator just to make sure that, yes, I know you should be able to do this by hand, right? These aren't hard. This is not a hard antiderivative, basic U substitution. But it's always good to be able to check your work in your calculator, right? So what we're going to do, from the main blinker screen, we're going to press Math, and you see option number 9 is FNINT. So that's an integration. So what we're going to do is we're going to integrate from 0 to 5 of $3,000 times E raised to the negative 0.04. Now I can't use t because our calculator likes x for the variable, but that's okay. Let's do x dx. And we're going to get our answer of 13,595.19. All right, and we'll say dollars, so we'll round to the pennies. So what does this mean? Well, what this is saying is if somebody were to offer you a continuous income stream of $3,000 per year for 5 years, how much would it be worth today? So kind of what that means is, for example, somebody has promised them, I'm going to give you $3,000 a year for 5 years, but I don't want the investment. I need the money right now. What can you give me right now? And then you can take the payments of the $3,000. Well, what this is saying is under the assumption that you can make 4% in the stock market or the bond market, you can make 4% doing something else with your money, you should not offer them $15,000 today. That's not a good deal. The break even would be $13,555.19. Because if you took $13,595.19 and put it in the stock market or put it in a bond market or whatever, and if it paid 4%, that would be equal to $15,000 over 5 years. So that's what it is. That's what it's for. And it's kind of fun because now you can kind of understand how much a business is worth, how much you should offer somebody. So if you're going out into the real world and you want to buy somebody's accounting firm, they're getting ready to retire and they have this book of clients. Well, you can look at their data, and this is one of the basic calculations that you do to figure out the value of the company. How much should you pay them for their company? Another fun example. Same idea would be something like the lottery. Okay, so let's do this problem. And as an example, So when you win the lottery, you were given two options. You can either take what's called a lump sum payment. You can take $11 million payment today and do whatever you want with it. Or you can get paid $1 million a year for the next 20 years. The question is which one should you do? If you are assuming you can make 7% interest on investments over the next 20 years. So if you already think you can make 27% using something safe like bonds or whatever, which is the better deal? Do you take 11 million today, or do you take 1 million a year for 20 years? Well, so if you want to, try to pause the video, try to fill in the values and see what you come up with. All right, I'm going to do the problem now. So we are going to go ahead and fill in. Now, 0 means starting today, and then we're going to go over 20 years. So I'm going to go up to 20. All right. Now, what is our amount that we're getting each year? Well, $1 million a year times e raised to the negative. Our rate is 0.07 t dt. All right, let's bust out the calculator. Okay, so this time I'm going to put in the calculator, but I'm going to do it using the old operating system. So that way, if somebody out there is using the old operating system, they'll know how to type it in. So the first thing we're going to do is we're going to go math. We're going to go FNINT, which is option 9. And how you do this in the old operating system is you just start by typing in the function you want to do the derivative or the antiderivative of. So you're going to just type it in just like you would have in the other operating system, right? You're just going to do that. Okay. Then when you are done typing in your function, you are going, I hope I have enough zeros there. 1, 2, 3, 4. Yep, we're good. Okay. Then you're going to put a comma, and the comma is right above the 7. And you're just saying, now what is my variable? Well, in my function, I used x as my variable, so I'm going to do x. Then you're going to do another comma, and you're going to say, what is my lower bound? Well, my lower bound was 0, comma, and then what is my upper bound? 20. So then when you hit enter, it'll give you your answer. Okay, so now you guys have seen it. New operating system, old operating system, fantastic. So this means our present value, there we go, is 1076290.52. All right, so according to this logic, if you think you can make 7% in the stock market per year and you're offered $1 million a year, then the present value of that would be $10,762,900.52. So what does that mean? What does that mean? So if you're saying to yourself that if the present value is worth 10,762,000 and you could get offered 11 million today, you should just take the 11 million. You're absolutely right. You should. All right. But now, I already did this in the calculator. Let me show you here. What if instead of 7%, what if we said I can only do 4%? Then how does that affect the logic here? Well, you could see if we do 4%, then it would be worth 13,766,775. So what does that mean? Well, then you should absolutely take the payments, right? You would rather take $1 million a year if you're only going to make 4% on your money. But what you can kind of recognize here is the higher the percentage rate, the less that it is worth today, because that money is going to be able to grow faster if the higher interest rates are higher. So as interest rates go up, the value of your continuous income stream payments go down, because the amount that it's worth today is less than it would have been otherwise. Awesome. Yay. All right. So that concludes our section here on present values. I'll see you in the next video.